f of x, where we said, well, just make this y and solve the problem. That's exactly what you're going to do. Now, I want you to know something. This is not part of the question, but I want you to just have this at the back of your mind. F inverse of f of x is always 1. G inverse of g of x is always 1. Because it's like you're doing the opposite after doing the right thing. So you do a forward reaction and a backward reaction. You cancel out whatever you've achieved. So it always goes back to 1. That's just information anyway. So let's go on now. I'm very conscious of the time. I'm very conscious about that. So we can now go into linear equations. Algebraic equations are, now what are linear equations? It's just like a function that tells you what x is and what, you know, what y should be if you know what x is. So equations of a line. Equations of a line. The general expression for the equation of any straight line, take note, straight line, because we've got so many kinds of lines these days. How do I spell straight? All right, the general expression is y equals to mx plus c. You must have seen that many times, but you're wondering, what does this mean? Well, this simply tells you that if you know what the value of x is, and you know m and c, you should be able to tell what y is. For instance, y equals to 2x plus 1. I mean, if you know what x is, you can know what y is. Now, any equation that looks like this is a straight line. It's so straight that you don't need more than 2 points to plot it. M represents the gradient. So we call M the gradient or the slope. C represents the y-intercept. So it's the y-intercept, okay? Now, what do we mean by the y-intercept? If you've got a graph sheet where you've got x and y, and this, for instance, is a line, a very straight line. If this is the straight line, any point where it touches the y-axis is the y-intercept, and that is your value for C. So C can be a negative value or a positive value depending on where it touches. What do we mean by the gradient M? If you look at this line, you'll notice that it's like, it's a slanted line, isn't it? Now, the degree of slantness is what we used to talk about when we say the gradient or the slope. For instance, this line and this line, which has, you know, a more pronounced slope, which has a higher gradient. Well, this has a higher gradient than this one because this is almost flattened out, but this is almost vertical. When it is very horizontal, it's totally having a gradient of 0. And when it's totally vertical, it has a gradient of infinity. So your gradients can go from 0 to infinity. Yeah, it can. And that's it. Okay. All right. But let's see what we can do with that. What's the property of a straight line? What do we need to know about a straight line? A straight line has got a fixed gradient. A straight line has got a fixed gradient. So y equals to mx plus c. M is the gradient and it doesn't change for that straight line at any point of the line. Whereas for a curve, the gradient changes, and that's why it's got ups and downs. So that's a fixed gradient. It's got a fixed gradient. And also, it passes through just one point. It passes through some points, but when you know 2 of those points, you can as well draw the straight line. You don't need several points for that because it's straight. And any line that has x in this form, you know, it's not x squared, it's not x cubed, it's not x to the minus 1 or anything. If it's just x in the equation, then it's a straight line. You can give examples of straight line equations. So let's look at this example.